Hello everyone, welcome to the 8085 programming series. Today we'll be doing the program 10 bytes of data stored in memory location starting from 8040. So write a program to find the positive data bytes and store in memory location starting from 8050. So we have 10 data bytes from 8040 to 8049. It may contain some negative, some positive numbers. So we assume that whatever data which is stored in the memory location, it is a signed number. Generally we use unsigned numbers, but in this case, because we need to consider positive and negative data, so we are considering the signed numbers. Okay, so this is the particular program. Okay, so before doing the program, let us study the logic behind this. What is the logic in finding the positive and the negative numbers? So as we can see in this case, okay, we have some data stored in register A. Okay, so we assume that the data which is in register A is suppose 78. Okay, and 78 if we write in binary, 7 is 0111 and 8 is 10000. Now if this number is a signed number, if this 78 is a signed number, then the leftmost bit, it determines the sign of the number. If this number is 0, the number is positive. If this is 1, it is negative. Okay, so with because this is the sign, the D7 bit. Now when we rotate it left, okay, when we rotate, because rotation is done with respect to A, so we need to bring the data from memory to A and then rotate left. So when we rotate left, if this data bit goes into the carry, okay, if you use RAL, rotate left through carry, then if we rotate left, this particular bit, it goes into the carry, and carry will be, because this is 0, carry will be reset. That means this number is a positive number. Now in case, suppose if we have some number, like suppose if we had, instead of 78, if we had 88, so just making a change, this is 88. Okay, so then we would have this 1, this would be 0, this would be 0, this would be 0, and this is 1000. Now with rotate left, this bit will go into the carry and carry would be set. Okay, and if this is set, it means this is a negative number. So this 88 would be a negative number. So in fact, in case of 8085, because we are using hexadecimal notation, so the smallest number would be 00 and the largest number, the last number would be FF. Okay, now in between this, all the numbers which are starting from 80 to FF, this would be the negative numbers if it is given a signed numbers. Okay, this is the condition. If this is a signed number, then from 80 to FF, all the numbers would be negative number, and from 00 to 7F, okay, these all numbers, they are positive numbers. Okay, so when we are doing this memory operation, we need to store some data into the memory. So I've just stored this randomly. So at 8040 I have stored 78, then 8041 we will store 89, and so on. We will store some different numbers also. So we need to store some numbers which are less than 80 and some which are more or maybe like which are more than 80 or maybe equal to 80. Okay, so all the numbers which are greater than 79. Okay, so then these numbers, all the numbers which are greater than 79, they would be positive, greater than would be negative numbers, and one which are less than 79 or 79, okay, which are less than equal to 79, okay, less than equal to 79, they are positive numbers. So in this case, if we consider this particular list of numbers, a string of numbers, then this because we want to select positive numbers, so this would be positive because it is less than equal to 79. So this is positive, this will be positive, this will be positive, this will be positive, and this will, and rest all are negative numbers. Now let us see how we do this program. Okay, so the first one is, of course, we need to initialize the source pointer, destination pointer, then set the count, okay, and then bring the data from memory to register A, and then we rotate left through carry. Now with rotate left through carry, if carry flag is set, we are giving the condition JC. So if carry flag is set, it means the number is negative and we need to skip. Okay, so if it is negative, then we skip. It is given, so with JNC, it will jump to this 8010. So this is the skipping part. Okay, it will INXH, then DCRC, jump if no 0 to again 8008. It will go to the next data byte. Okay, and if we do RAL, and in case if carry is not generated, then we know that that number is positive and we need to store the number in that case. Okay, so this is how this will work. Okay, now let us execute in Jubin simulator. So this is the required code. Okay, so this is the code. Okay, LXIH8040, then LXID8050, and then here we have the instructions. So I have copied this to this Jubin simulator. So this is the required code. I will assemble the code. Okay, so after assembling we get this. Okay, and after assembling, of course, we need to store some data into the memory. Okay, so I'll just come here, show directly, and we'll store some data in this case from 8040 to 8049. Now we store the data in such a way that some data are less than 80 and some are more than 80, so that we'll get some positive as well as negative data bytes. So I have stored this data. Okay, 7882 A2, then 8923, and so on. So you can see these are the data bytes. So all the one which are less than and or equal to 79, so they will be positive data and they will be stored. Okay, now let us execute the code. So with the first step, okay, this is what we get with the first step: LXI H8040, then LXI D8050. We get this data in D register pair, and we just get C equal to 0A. Here we get C equal to 0A. Now we bring in the first data byte from the memory location 8040 to A, and of course it is 78. Okay, and then when we rotate this left through carry is not generated because this is a positive number. Okay, now actually data byte has changed, so it will not jump because carry is not generated. Okay, so we again bring back the data from memory because it has been changed by RAL instruction. So this is 78. We store it to STX using STAXD, so that this data will be stored in this location 805. You can see this is stored here. Okay, and then with INXH we go to the next memory pointer of destination 8051. Then with INXH we go to the next memory pointer of the source, then DCRC. Okay, and then JNZ. Okay, and then it will go up again. The second data byte is A2. Okay, now A2 it is greater than 79, so of course it is a negative. With RAL you can see the carry flag is set. Okay, carry flag is set, so it will not store, it will jump down, jump off. If carry, you can see this part is skipped, it goes to the next memory pointer 8042. Okay, and this will continue. Okay, this will go on. I'm just doing it quickly to save time. Okay, and when the counter becomes 0, we are done. Okay, and we'll check the result. Okay, so the counter has become 0. Now let us check the memory content. We can check the memory content. All the data bytes, they are less than 79, we get this, we get it here, and all which are greater than 79, we can check it, they are not coming here. So this is how we do the program for the positive data, selecting the positive data byte. Now what to do to modify the same program for getting the negative data byte? Okay, we come to the editor mode. Okay, and instead of JC we just type JNC. Okay, we just type JNC. Okay, and then assemble the code. Okay, after assembling, then store the data again. We need to store the data coming this to this mode. Store the data from the top memory location 8040. Type here 8040 and type again some data bytes. Okay, and after executing we will get the negative data bytes. So that's how we do this particular program. Okay, for negative and positive numbers.